Hello everyone, my name is Sulaimon Afolabi. I'm here together with my colleagues whose pictures you can see on the screen. We are here to take you through a teaching, or you can call it a tutorial, on how to implement a data science project. This is actually the R version. And just like the Python version that was posted earlier on, this promises to be a hands-on approach. I just want to use this medium to talk briefly about my team. Actually, these people saw the first version, which was in Python format, and they volunteered to actually convert the Python code to R. And you can actually pause this video if you want to learn more about them, their names, and also their affiliation or companies or institution. And I must confess, I really appreciate their effort. Now, one approach that we'll be using, and just like we did in the first version, is to adopt a machine learning approach. And by the way, what is machine learning? Machine learning is that field of study that gives computer the ability to learn without being explicitly programmed. So in the context of machine learning, we don't program our way rigidly from one point to the other. What we just do is that with the aid of algorithms, we give computer data, or call it information, and computer, based on the information, the data that it has been given, can be able to make decision, can be able to look for patterns, can be able to predict. So we gone were the days when we need to program computer to move from A to B. This time around, we don't do that. In the course of this teaching, we are going to be making use of a number of tools. And my colleague, Ahmad Bello Abdullahi, we take it from here. Thank you and stay tuned. You will soon hear my voice again.
Hello everyone, my name is Ahmed Bello. This slide contains some of the R packages and tools that we will use in this project. We are going to use the R programming language, and we are going to make use of the R Studio. It is an integrated development environment that makes writing R code easy and interactive. The packages we are going to use in this project include the dplyr package, which we are going to use for data manipulation. Things like selection of rows or columns and joining datasets can be done within this package. The second package is the ggplot2 package. We are going to use ggplot2 package for data visualization. The tidyr package will be used to tidy up our dataset. The readExcel package will be used for reading data in Excel sheet that have been produced by Microsoft Excel into R. And lastly, we are going to adopt and evaluate a machine learning model using the caret package. Next, we have the outline. The first thing we are going to do here is project description and checklist. Secondly, data loading, merging, and visualization. Thirdly, we do feature cleaning, selection, and transformation. We then adopt a machine learning algorithm. And lastly, model evaluation, fine-tuning, and assembling. We will start with project description and checklist. We are going to use machine learning techniques to perform exploratory and predictive analysis on crime data. Dataset A contains data on reported crime and respective police station across South Africa for the year 2015 and 2016. Dataset B contains the name of police stations and population that fall under their jurisdiction. And the dataset C contains locations, that is the geographical coordinates of the police station across South Africa. Dataset D is an additional dataset. Later in the course of the project, we will source that. Next, we need to know what the problem is. Is it a supervised machine learning problem, an unsupervised machine learning problem, or a reinforcement machine learning problem? In a supervised machine learning problem, computers learn by example. In an unsupervised machine learning, computers learn by searching the data and trying to find a pattern in the data set. And for reinforcement learning, computers learn by trial and error and experimenting within the data set. A supervised machine learning aims at predicting values, while an unsupervised machine learning aims at finding patterns within the data set. And reinforcement learning aims at making decisions in the data set. The next slide tries to show us the characteristics of supervised learning, unsupervised learning, and reinforcement learning. We can see under supervised learning, the outcome of the future is known. And supervised learning is task-driven, and it tries to fit the data. Its goal is to predict values in continuous, which can be a regression problem, or a categorical, which is a classification problem. In an unsupervised machine learning, the outcome of the future is unknown. Therefore, the problem is data-driven. And this, in reinforcement learning, the outcome of the future is unknown. Therefore, the learning is completely circumstance-driven, and decisions is made on the data. And its goal is to learn how to make certain decisions based on a given circumstances. In a supervised machine learning problem, levels can either be continuous. For example, the burglary level, you can see it contains numeric values which are continuous, or it can be categorical, as we can see from the frequent crime level, which has different categories of data. The regression method can be used to solve a continuous supervised machine learning problem. And classification is the method that is used in order to solve a categorical supervised machine learning problem. So the first procedure now is for us to understand the problem and see if it's a supervised problem or unsupervised, or if it's a reinforcement machine learning problem. And secondly, if it is a supervised machine learning problem, is it a classification or a regression task? And third is for us to identify the target future or futures to be clustered. And the fourth task on the checklist is to ask, can we get extra data or future to boost the project that we have at hand? And then next is, what are the available solutions to the problem? Then we move further into asking, how do I intend to measure the performance of my model? And how will my solution be deployed and utilized after the model have been created and the performance of the model have been evaluated? How can we now deploy the model and use it?
Hello. At this stage, we'll be talking about data loading, data merging, and data visualization. But before we progress, let's talk about data form. Our data can come in different form. I want you to take note of that. And specifically for this project, we are going to be using data that are in alphanumeric. And also note that you can have data in coming to you in an image form. Also, you can have raw text data that you are expected to analyze. Also, audio and video as well. So I want you to note that this is not an exhaustive list of the data form that you can have. You can have data also coming from the medical field and other fields stored in different form. So I want you to take note and be aware of the different kind of form. Now let's go to the data loading checklist. Number one question you must ask yourself is, where the data set located? That means the data set that you have been asked to analyze or that you want to analyze for your project. Is it on your computer? Is it on the server, company server somewhere? Is it on the web or even in the cloud? So we have talked about this previously. So the next question is the data set, the data is in what form? Alphanumeric, text, image, audio, video, etc. Data flow. Is it a real-time data? Or does it come as a stream or in batches? That question must be asked and answered. Data size. How big is the data size? Is the size in kilobytes, megabytes, gigabytes, or terabytes? And that will determine, will lead us to the next question, the analysis platform. Can I analyze my data on my computer or laptop? Or I need to engage the service of cloud-based computing provider, e.g. Microsoft Azure, Amazon Web Service, AWS as it is popularly known, or Google Cloud. So now when it comes to loading our data, the number one thing is to start our RStudio. Just like Ahmad made us to understand, our IDE, Integrated Development Environment of choice as far as this teaching is concerned is RStudio. So if you have installed yours on Windows, you can just go to Start menu, RStudio. I want to assume at this juncture that you have already installed RStudio. If you have not done that, you can just go to your browser, Google RStudio, then it will take you to a link where you can download and afterward install it. So as you start the program, this is the window that will come to you, and they serve different purposes. Let's start by going to new file, our scripts. You can see we have a number of options there, but we are going to select our script because we want to write some code. A pane like this will appear, and 4 panes are involved. The script pane, as you can see on your screen, is for writing code. And when you finish writing code, you type Control Enter to run your code. The next pane allows you to type your code directly, and also it provides an avenue to see the results of your running your code in the script pane. The third pane comprises of environment, the history, and the action. And it is here that you also find the data sets, the property of the data set that you have loaded. Once you do that, the last but not the least is for packages, for file, for your plots, for your viewer and the like. When you run your code that entails that the output is a graphic or is a plot or a chart, it will automatically switch to that mode. It will switch to the plot mode. Okay, here are the data loading steps. So the step number 2 is to import the necessary hard packages. For example, we are going to install these 3. So I want you to note that the installation is once and for all. So that means you should not be running this part of the code every now and then. In fact, once you run it once, it's advisable to just comment it out. And this is not, we are not going to just be running these 3 alone. So that's why I want to implore you to get the code that comes with this presentation. You will see all the other packages that we are going to install and that we are going to load. Step 3 is to load the packages. So we use library code or command to load them. Again, I must emphasize the fact that we are going to be loading more than 3 packages. Step number 4 is to set the working directory. So make it a habit to always do that. So that is my directory. It's actually a folder on my computer that I would like the my course to be stored and the other relevant document. Step number 5 is to load the data. So you can see on the screen there the codes that are needed for you to be able to do that. Now my colleague, co-presenter, Kamaldin, we take it from here. We highlight the practical step that you need to be able to load data and do some other interesting stuff. Thank you and stay tuned. Okay, here are the data loading steps. So the step number 2 is to import the necessary hard packages. For example, we are going to install these 3. So I want you to note that the installation is once and for all. So that means you should not be running this part of the code every now and then. In fact, once you run it once, it's advisable to just comment it out. And this is not, we are not going to just be running these 3 alone. So that's why I want to implore you to get the code that comes with this presentation. You will see all the other packages that we are going to install and that we are going to load. Step 3 is to load the packages. So we use library code or command to load them. Again, I must emphasize the fact that we are going to be loading more than 3 packages. Step number 4 is to set the working directory. So make it a habit to always do that. So that is my directory. It's actually a folder on my computer that I would like the my course to be stored and the other relevant document. Step number 5 is to load the data. So you can see on the screen there the codes that are needed for you to be able to do that. Now my colleague, co-presenter, Kamon, then we take it from here. We highlight the practical step that you need to be able to load data and do some other interesting stuff. Thank you and stay tuned.
In this section, we want to look at data loading, merging, and visualization. To start with, we will look at data loading. We have been given 3 different sets of data. Dataset A contains information about the crime reported at different police stations. And we have been made to realize that the data set is in CSV format. CSV format is comma separated value, that format. So in order to load that, we use the keyword read.csv. Then we reference the name of the file, and that is what you can see there, dataset a.csv, because it's in CSV format. So that the code can go as thus: read.csv dataset a.csv, and it is now assigned to a variable name dataset a. Having read that, we assign it to a variable name dataset a. The next thing is that we want to sort the record using police station, so that we can bring out all the police stations and the different crime category that we have. So to do that, we call the variable dataset a, but we call it based on the column police station. So to do that, we have dataset a. You can see the kind of bracket we are using there. That kind of bracket is used when you need to call the variable, the information about a particular variable. So we are having the information based on police station. So it will definitely arrange them based on the police station name. The next thing is I want to view what we have done in sorting, to view the top 6 records. Actually, to view the top records, we use the keyword head. To view those records below, maybe towards the end, the last 10 or last 20, or we use tail, the keyword tail. But because here we want to view the top one, that's why we are using head dataset A. By default, it will give us the first 6 records, and that is what you can see there. It has arranged them based on the police station, Aberdeen, and at the same time, the different crime category. That is what you can see there. The next thing is that we want to look at the structure of the data set to know the number of variables and observations there. To do that, we use the keyword str, which stands for structure, str dataset A. If you put that in your R Studio and you run it, it's going to give you the information below. In that information, we can see that we have 30,861 observations, and which are 4 variables. The variables are those ones listed there: province, police station, crime category, and the period. So that is what you can see there, and that has given us the kind of information about those variables. The next thing is that we want to we need to reshape the data set. The 30,000 plus observation is true. Let's see how we can reduce it. So to do that, we need to reshape the data set. How can we match some things? The long format, how can we change it to a wide format so as to reduce the number of columns we'll be having, so that perhaps all the police stations can be grouped, so that we have a police station then we have different kind of crime rates or crime category. So, and that is what you want to do here. You want to look at, you can see here that the 4 different column, the 4 different row, has been converted to just one row and then several columns. You can see all theft not mentioned. We have been able to create a column for that, and so on like that. Different crime category about a police station. So in order to execute that in our R Studio, we are going to use the keyword spread. Spread will do that for us. It's one of the packages, or it's one of the packages we use in data manipulation. We must have earlier on called the library tidyr. So that is where we can find the keyword spread. So if library tidyr has been called earlier on, then we just have this code spread dataset A, crime category, and the period. We want crime category to be we should have columns for crime category. We should also have a column for the period. So if you use that, spread dataset A, crime category, then period, and you assign that to dataset A wide. So it's going to do what we actually want to do for us. So to now view what we have done, whether we have done it, whether it has actually done it, we can always use the keyword add dataset A wide. Then here we just want to limit our records. We have said by default it's going to give us 6 records, but we just need 5 of the records here. So that is why we define n equals to 5. And the result is what you can see there. It has been able to have all information about Aberdeen. It has limit everything. It has limited it to just a row. You can see all theft not mentioned, the number, and so on like that. The same thing for Ado, the same thing for Adelaide, and so on like that. Alexandra, we can see that. So it has done that for us. Now we also want to, since we have done that, we want to know whether our 30,000 plus observation has been reduced, because that's the aim. So viewing the properties of the reshaped data set, we realize we have structure. To view that, we use the code structure of dataset A wide, and the result is what you can see below. We have 1,143 observations, which is of 29 variables. You can see that it has actually reduced. So it has listed all the variables that we now have. Province, we now have several variables as against what we have before. So we have province, we have police station, all that, and so on like that. Those are the variables that we now have. The next thing is I want to see whether what we have done has been done correctly. Let's see whether there's any duplicate information. Maybe information about a police station has been duplicated. In order to do that in our R Studio, we use the keyword as shown there. So the code will now be length duplicated dataset A wide by police station. We want to view whether the police station aspect has been duplicated. Do we have a police station that is being reported twice or more than twice? majorly more than once. So it returned 1,143, which is the same set of number of observations that we have. So that actually shows that nothing has been duplicated. Dataset B contains information about police station and the population that each of them cover. The dataset is in MS Excel format. In order to read that in RStudio, we must have installed a package earlier on. So if that has not been installed earlier on, it means there's need for us to install it now. And how do we do that? We use the keyword install.packages so that we have install.packages XL, SX. Then having installed that, we load the library with library XL, SX. So if those two things have been done, then we can proceed to reading the dataset B. So how do we go about that? We use the keyword read.xl.sx. So and then we reference the name of the file, which is dataset b.xlsx, so that we can have read.slsx in brackets dataset b.xlsx. So having done that, we assign it to dataset B, variable dataset B. So like we did for dataset A, we have want to sort the information about dataset B too. So how do we do that? We call the variable name dataset B, and we call it based on the column police station. So column police station, we have dataset A, dataset B by police station, dataset B by police station. We do that. Then by running that, it will automatically arrange the information according to the police station in alphabetical order. So to view what we have done, we can view the top 5 records. To view the top 5 records, like we have said earlier on, the keyword head by default usually give the first 6 records, but here we have defined n equals to 5, so it has given us the first 5 records. The next thing is that we want to look at the structure of dataset B. To do that, we use str dataset B, and it made us realize we have 1,140 observations, and which are of 2 variables. The variables are police station and then the population estimate. Likewise, we also want to know whether there are duplicates in our dataset B. We want to see whether there are duplicates, just like we have done in the other one too, in dataset A. So to do that, we also use the code length duplicated dataset B by police station. So it gives us 1,140 record, which is also the same as the number of observations that has been reported earlier. So it shows that we don't have any duplicated information. Then for dataset C, it contains information about police station and their geo coordinates. The dataset, as it has been shown there, is in CSV format, that is tab separated value format. In order to load that, we use the keyword read.table. Read.table, then we reference the file, which is dataset C.tsv, because it is in TSV format. Then you can also see another thing there that we have header. It's saying that header is true, that truly we have header there. To know that whether the table has heading or not, and that is what you can see there, header is true. So we have the code read.table dataset c.csv, header is true, and separated with that. So, and having read that, we assign it to a dataset C. The next thing is that we also want to sort the information about dataset, just like we did earlier on. Dataset C. Then we have we call the variable dataset C by police station. So to view what we have, you can see we have we want to view the top 5 records. We want to view the top 6 records. So to view the top 6 records, we use add dataset C. So you can see what it has given us there. It has arranged the dataset based on the police station, and just like we have done in the sorting, we have Aberdeen and so on like that. It has done that and given us the information about them. Now let's view the structure of dataset C. To do that, we use str dataset C, and then we can see that it has 1,142 set of observations, which are of 3 variables. The 3 variables are police station, longitude, and the latitude. So you can see that there. So that is for the structure. The next thing is that we want to check whether there are duplicates. To check whether there are duplicates there. So in order to do that, in order to check for duplicates, just like we have done in the other ones, we can also use another code here. You can see dataset C duplicated, dataset C by police. We call that the variable to check whether there are duplicates based on police station. Whether we have a police station that occur more than once, and we realize that it will return all of them, that there's no incident of duplicate records. So, and that is what you can see as it has brought out no one. So meaning that there is no incident of duplicate record. Now we want to see how we can merge all the data sets together. We have dataset A, dataset B, dataset C. And we realize that they have different records, number of records. For dataset A, we have 1,143, B is 1,140, and C is 1,142. And we realize that we have some features common to them. A feature, to be specific, that's a police station. You can see it's common to them. So in order to do that, we need to merge them one after the other. First, merge A and B together. So to do that, we use the keyword left join. But we can just let our R Studio give us information about the size of the dataset, each dataset. To do that, you can say paste size of dataset A, so as to know which one will be the universal dataset. And so to join that, we use left join, so that dataset A can be at the left-hand side, dataset B will be at the left-hand side for the join. So we have left join dataset A wide, dataset B. We want to join them by police station, because police station is common to both of them. So we're going to join based on the police station name. So, and that is what we have there. we need to note that the two data sets were merged using a feature that is common to them, and that is police station. And that data set A is on the left, based on the way we have joined. Data set B is on the right. So we want, the reason why we have done that is because we want all records on the left to be universal. And that is why we have given that left join. Since dataset A is universal, it has the larger number of records. So it's the universal, so it will be placed on the left-hand side. And that is what we can see there. So to merge dataset C to it, since we have the last variable name to be dataset A, dataset AB. So we also need to confirm the number of our records. That's why we have the paste size of dataset B to be equal to the number of rows of dataset A and AB, and that is what it returns 1,143. For dataset C, it gives 1,142. It means dataset AB, which is 1,143, will be the universal. So to join that, we use left join dataset AB, dataset C. We are joining based on the feature that is common to them, and that is police station. So that is what we are using to join. So as a result, it will place dataset AB on the left-hand side since it is the universal, and while dataset C will be on the right-hand side. So that is what we need to do when we want to merge your data set. Thank you.